Hi there, my name's Ebrar, and I wanted to show you a Node React app that I've been working on. So I want to quickly walk you through the source code, show you the different technologies the app is using, and show you how everything works in development and production. So this application is mostly an LMS or a learning management system style application where users can come in and they can purchase and enroll in different courses and information products. So they can click through to a checkout page which looks something like this, and over here they can enter their payment information and submit the order. And if they're allowed to enroll in this course, their payment will go through, and if the payment is successful, they can activate their account and then they can log in. And the login page looks something like this. So after they log in successfully with their email and password, they're taken to the dashboard, which looks something like this. And over here, they can see their orders, other informations, including the courses that they have enrolled in. They can click on one of these courses to go into the learning area for that course. And this is where they'll see all the different lessons for that course. And this is where they can consume all the course's content, like videos, articles, quizzes, and everything else the course has. So this is how this application works, and these are the main basic parts of the application. So now let's jump into the code editor, and I'll quickly walk you through the source code, highlighting the different features, and I'll show you how everything works under the hood. Okay, so first of all, this app is a bit of a modern SPA or a single page application, but this app also follows a lot of the principles of cloud native development. So you have of course, the containerized applications, but also CI/CD pipelines and automatic deployments and stuff like that, which I'll go into in a minute. And this app also sort of follows the Jamstack principle, which stands for JavaScript, API, and markup. So that's basically how the app is designed, and that's sort of the architecture the app uses. Now, in the backend, which in the source code, as you can see, is inside the API folder, the backend is powered using Node, so Node.js, and I'm using the Express framework. So you can see in the main app.ts file, this is like the main entry point for the backend server, and here I'm using Express to initialize the server, and this is where all the things like the routes, the queries, the GraphQL API, which I'll talk about, everything resides here. This is like the main entry point for the backend server. So in the backend, I'm using Node and Express, and in the front end side, which is under this web folder here, I am using React with Next.js. I'm using React with the Next.js framework, and you can see the main page, the underscore app.tsx. This is like the main core Next.js page that they have in their framework. And originally, actually, I used the Create React app toolkit that's available with React. So I used that, and that also means that I used the client-side rendering that comes with the Create React app toolkit. But then I switched it over to Next.js, and then at one point during development, I actually switched almost all of the app to use server-side rendering, which Next.js supports. But ultimately, I decided to use static rendering with client-side data loading. So that's how the front end is built with React and the Next.js. You'll also notice that I'm using a lot of more modern, newer JavaScript features and syntax, things like the import-export keywords, constant declarations, arrow functions, and I'm also using, async await keywords and optional chaining operators in other places. So a lot of ES6, ES 2015 plus JavaScript code there. So a lot of the ES Next style JavaScript, and the code is also commented. So you can see comments all over the code on front of different functions and in different complicated areas, explaining what the code does. So the code is documented and following best practices like that. And on the front end side of things, you'll also notice that with React, I am using newer, more modern React syntax, such as function components instead of class components. So as you can see here, these are function components, and I'm also using hooks extensively. So using hooks such as the use state and use effect hooks, and also other hooks from different packages and libraries. So using those more modern, newer features of React, which have their own benefits. And I'm also using Redux for state management. So most of the state of this app is actually managed by React's own useState hook inside the different components and pages. Some of that information is stored by the Apollo client cache. So this app does use GraphQL and Apollo client, so that caches some of the data. I'll get to that in a minute as well. But some of the state is also managed by Redux. So Redux mainly manages like the one-time notification messages that show up when you take different actions. So you have like an alert notification message and a notice or an information notification message, and that's what Redux handles, because that's like state that's shared all across the application, and that is what Redux manages right there. So that's how the front end with React works, and the back end uses Node. And in terms of the database, I'm using MongoDB. So it's a NoSQL database, and it integrates really well with JavaScript based Node.js and even the React in the front end. So it's like a JavaScript stack completely. Also using the Mongoose library or package to interact with the database. So over here, as you can see, I'm authenticating to the database with like the username, password, and the connection. And over here, I have the different Mongoose models. So as you can see, I have defined the schema and the different hooks, the different functions, along with each model. So you have all the different models with their information, and they're all stored here. So that's how Mongoose Mongoose is used to interact with the MongoDB database. So that's how the Node, React, and MongoDB works. And you'll also notice that I'm using TypeScript. So this app does have strict type checking enabled. So I'm using TypeScript, and all the types are defined in this file. For example, this is like all the most commonly used different interfaces for the different data types. So this is stored in this types file. I also have a types extensions, and I'm using these types all over the code. I'll show you some of the resolvers which have like more types in there. So a lot of the types which are not reused, they're put inside the files. So you'll see different interfaces here, and I'm also using all those common interfaces all throughout the application. And the code, everything where it's needed, it is annotated with the types. And the front end also uses TypeScript. So front end has their its own TypeScript interfaces, and of course the different pages that I showed you, they also have their types defined here. For example, all the TypeScript is used. And then onto the API side, the backend is an API. And in terms of API, it currently uses GraphQL for the most part. So originally it used completely a RESTful architecture, but then I converted most of it to use GraphQL. So here you can see right here, we're getting all like the resolvers, the queries, mutations. You can see the GraphQL schema here. We have the different queries, mutations, the different unions for error handling, and these are the different types, the input types. All these things are defined in the schema. And here you have the resolvers, the different resolvers which handle all the different queries, mutations, and everything. So that's handled by all these resolvers. And I'm using the Apollo server in the backend to run the GraphQL server, and also provides the GraphQL playground. And on the front end with React, I am using the Apollo client. So here, as you can see, I'm defining like the different queries and mutations, and I'm using a lot of the Apollo client's hooks, such as the use mutation hook and use query, use lazy query, all these hooks to run these different queries and GraphQL queries to get the data. And of course, Apollo client is very efficient in that it caches a lot of the data, and it can dynamically update it as well. So that makes for a great user experience on the GraphQL side. But a few of the routes, they still follow the traditional RESTful API convention. These are mainly the webhooks which need to follow the RESTful API. That's why they use non-GraphQL, basically traditional HTTP based RESTful routing structure. So you have different webhooks for like drip and Stripe payments because this does handle payments. I'll get to that in a minute as well. Now, this app also has a suite of tests. So the tests, they use Jest right now, although originally I used Mocha and Chai to create those tests, but then I switched over to Jest. So I've used Jest to write tests for the backend here. As you can see, we have some configurations. They're like some common configurations, different hooks for like database and E2E tests and stuff like that. And most of the tests run in parallel. So here I have some of these tests. These are mostly integration tests. So some of them are unit tests, but mostly integration tests. Here you have tests for the models, the different models, the different functions and everything that they have for the models. So we're testing them with different test suites here. And I also have tests for resolvers. These test the resolver methods directly of the GraphQL API. And I also have a GraphQL API suite of tests, which basically test the GraphQL API as is by actually querying the different GraphQL queries and mutations. So that's how I'm testing the GraphQL, both the API and the resolver methods. And some of them are unit tests, but mostly these are integration tests. And these all run in parallel. That's one of the benefits of using Zest. But I do have a suite of serial running tests there that run in band. And these are mostly E2E tests, which are powered using Puppeteer with Chromium. So this actually launches a headless Chromium browser to actually run these tests. So I have a suite of E2E tests as well to test, how a user would actually interact with the application. These are actually great for testing the whole system. So I have a suite of E2E tests. So that's how the serial E2E tests work. And these are just in the back end. In the front end, I'm also using Zest to write some tests which are what they call snapshot tests. So here I also have some different configurations, but these are like the snapshot tests which test individual React components. So it uses the React test renderer, I believe, to basically render the JSON tree of one component with the data, and then it takes a snapshot of that. So here you can see this, all the snapshots are stored there. And so I basically writing a bunch of these snapshot tests to take a snapshot of the UI of these different components and how they render. So that's how the testing side of things work with Zest. And like I said previously, this app is containerized, so it didn't used to be containerized. It ran like a normal typical application, but then I used Docker to containerize the application. So you have a Docker file here which builds the container image, and you run that image, and this is for like the API, and there's a separate different Docker files. So you have like two containers. This one's for the web, this one's for the front end, which it builds it builds the Next.js build and then runs it. So these are the two containers. They have one for the backend API and another for the front end React web. And then in the development, like in my development machine, I use Docker Compose to run these containers. So this actually defines three different services. You have the API service and the web service, which runs their respective containers. And you also have a database, because I'm using MongoDB, so I'm using an image of Mongo to spin up a database. And all of these work together with Docker Compose to actually run all these three containers and link them up with the networks and everything, with the ports and volumes to actually enable the development on my local machine. So that's how I'm running the containers locally. I'll actually show you. If I just run Docker Compose up, it'll start up the three different services, so the database, API, and web, and it starts up all three of them together, and then basically you can just access the front end on localhost 5000 and the back end on localhost 3000. So that's how I'm using Docker Compose during development. And in production, the app currently uses a Docker Swarm. That's the orchestrator that I use in production. I can actually see you have the Docker Stack configuration, which is what Docker Swarm uses. So this is similar to the Docker Compose file, but this is for production, and it has like multiple replicas. I'll show you the production server in a minute. But this has like multiple replicas with like zero downtime rolling updates with rollbacks in case of failures. So that's just all the things that are defined. So again, you have the web API and database, but this is for like production, running it with Docker Swarm as the orchestrator, using this Docker stack configuration. And that's how the app. That's what the app uses right now in production. I have though used the compose tool, that's composed with a K. I've used that tool to convert a Docker stack configuration into a Kubernetes configuration object. So, and I've put these things here. So as you can see, I have converted this. So the different things, they're converted into like deployments. So you have the deployment for the API, which deploys the pods, which contains the API containers. You have the API service for like the networking and ports and everything. The deployment for the database, and Mongo's persistent volume claim. That's for the storing the database data. You have a web deployment, web service, and a network and everything, and a secret for the secret storage. So all these are there. I haven't actually deployed the app with Kubernetes yet. I do plan on doing it in the future, but I haven't actually gone about doing it yet. For now, it uses Docker Swarm. And of course, I'm using Git for version controlling. And alongside that, I'm actually using GitLab. It used to be stored in a different repository, but then I switched everything to GitLab, and that's where the code repository is currently stored. So here, as you can see, this is like the repository for the application. And with GitLab, it's also great because GitLab has their own suite of a CI/CD services. So they allow you to define a CI/CD pipeline configurations, which I have in this GitLab CI YML file. So this is where I have 3 stages. This is like the full CI/CD pipeline of like this application. So you have the different stages: build, test, and deploy. So this is where the different containers are built. So that the API container and the web container, the development images, they're built, and then there's this test stage where all the 3 different tests they're ran. So the snapshot test, integration tests, and the E2E tests, they're all ran. And then you have the deployment where all the images are pulled, and then they're tagged with the comment SHA, and they're tagged for production, and then they're pushed to the registry again. And this also uses GitLab's own container registry that comes with it as well. And then using SSH, we access the development, the production server, and we actually do a rolling update, changing the image and updating the image of that service, and then doing some cleanup. I'll actually show you the production server right now. This is where I'm SSH'd into the production server, and if I actually list the different services, you'll see that it has like these 3 services. So the API, the web, and the database, running multiple replicas, a total of 5 containers for 3 services. Some of them are replicated. This is just a simple single node Docker Swarm cluster that I have going on here. So that's how the production server works. And this app currently doesn't have mostly like a DevOps sort of a development system, but considering that this app is already containerized and it has a full CI/CD pipeline with like production deployments, it should be like relatively easy to integrate this into a DevOps environment or a DevOps cycle or a system. And this app also interacts with a bunch of external APIs. So I already talked about the Stripe API because this app does have like payments, processing, and everything. So it does have an SCA complaint, strong customer authentication complaint, payment flow, and payment system that works with Stripe, including Stripe's payment intent, webhooks, and everything that it uses right here. So it has a payment integration with Stripe, and I'm also using Stripe in the front end, obviously, with React's own Stripe library with like Stripe elements and everything in like the checkout page, I believe. Yeah, that's where the actual payment is made. So it integrates with Stripe to facilitate the payments, and it integrates with a bunch of other APIs as well, such as the SendGrid API for sending mails, like emails, and also the Drip API, which is also another email service provider. For marketing reasons, it integrates with all of those APIs, and all of those are integrated into this application. And I'm also using a bunch of other smaller services and things such as I'm using ESLint to lint the entire code. I'm also using the VS Code's extension for that to make sure that the code, I'm using it in the back end and in the front end to make sure that the code it follows certain rules and patterns. I'm also using Prettier to automatically format my code, also used in both the front end and the back end. All using Prettier to make sure that the code follows a specific formatting style. And since I'm using Next.js, it also uses Webpack and Babel under the hood. I actually have a custom Babel configuration here, which has some plugins. But you usually don't have to worry about it that much because Next.js handles most of the Babel and Webpack stuff. But since it uses Babel, that means that all the code is very backwards compatible and can run in a lot of older browsers as well. And Webpack bundles up all the code, so it uses all those modern development principles and technologies that come bundled in with Next.js. It makes it really easy to use them. So that's how the Babel and Webpack configuration works. And for styling the front end, the app is mostly powered by Sass styles. So Sass styles with the SCSS syntax. This style sheet, that's what styles most of the front end of the app. Though I did recently introduce styled components. So here I have like a bunch of styled components that I've defined, and I'm starting to integrate them into the application. So it uses a bit of styled components, but most of the app is styled using the SCSS Sass style sheet. And I also designed most of the UI and the application myself. And so that's how the styling part works. And this app also, since it's like it uses a backend API and the front end communicates with the backend API, the authentication is done over JSON Web Tokens. So I'm using like a signed JSON Web Token to verify the user and make sure that the routes are authenticated and the information stays protected. So using those things like JSON Web Token, and the user's password is of course encrypted and hashed using bcrypt, so basic standard security practices like that. That's how like the authentication mechanism of this app works. And I am using the Visual Studio Code for code editing on a Mac with Mac OS. That's what I use for development. And lastly, I will show you. So this is like the actual production version, live version of the application. It looks very much like the development version, obviously, but this is like the actual live production website that is served by the production server. So yeah, that's about it. So I hope you enjoyed this little code walkthrough, and I hope you found it interesting, and I hope I was able to show you one of the real apps that I've worked on and showed you a real example of my work and the code that I write and the technologies that I use. And I built this app from scratch, by the way. So yeah, if you have a Node React related project that you want to talk about, you can just send me a message and I'll get back to you. And thank you for your time and have a great day.